Okay, this video is dedicated for the students who had confusion on how to do the last part of the quiz that I gave you last Friday. So if you remember, we had this kind of question for part 6 in which you will look at the given element, and the element that I gave you during that time, it was rubidium with an atomic number of 37, having an atomic mass of 85.468 or 85 as the nearest whole number, and its symbol, which is RB. So in the given direction class, you need to fill in the following. You need to write the SPDF notation of this element, either the longhand form or the condensed form. Next, you need to show the orbital box notation in relation to the condensed form of its SPDF notation. So in relation to this one. The third one that you need to do is to draw the Bohr model structure of rubidium. The fourth one is to write the number of valence electrons this element has. And the last one is to show to me the Lewis dot structure. So without further ado, let's start on how to do it. So this one, the one that I showed you a while ago, it's just the same. Should start here actually. Okay, so nothing here, and answered. Okay, so let's begin. We can see here the given element that I want you to focus, rubidium, having the atomic number is what I've said, 37. And we have here the guide that you've seen a while ago also, the guide for the condensed form of this element in its SPDF notation. This is also a guide for you to do the longhand form class. So let's deal the longhand form. The first thing you need to do is to write 1s, because this is the first one here. 1s followed by 2s followed by 2p. So here 1s, 1s2, because as what I've said and as what you've remembered, S sublevel can hold 2 electrons, followed by 2s2 here, followed by 2p6 because p sublevel can hold 6 electrons, followed by 3s2, 3p6, 4s2, 3d10. So for d sublevel, it can hold 10 electrons. Next, for p6, 5s1. Okay, if you will count all the electrons here, 2, 2 plus 6, it will become 10, then 12, then 18, 20, 30, 36, and 37. So a total of 37 electrons. Remember that a neutral atom, like rubidium, like this class, will have the same number of protons. So the atomic number represents the number of protons. So it will have the same number of electrons, a total of 37. We will just count the total. Next, let's do the condensed form. So the rule that I told you in doing the condensed form is to find the highest energy level having the p sublevel, in which that p sublevel has the complete number of electrons that it can hold. So here, as what you can see here, we have the highest level is level 5, but level 5 is until only to 5s. So we cannot use that. We need to find a level having p, okay? The highest one having p. So we have here the 4p6. And remember, a p that has the complete number of electrons, which is 6. So this one represents to the energy level, and it represents also to the period. So if you will count the period in the periodic table, we will start here, period 1, period 2, 3, and 4. So we will be using krypton as the isoelectronic of rubidium in its condensed form. So we will write krypton here. Krypton represents from 1s2 up to 4p6. Next, we will write the remaining one, which is 5s1. Actually, class, you can also write 5s only, because if there's no number here, it means there's 1. So you can write 5s1 or 5s. 5s is still correct. So this is the condensed form. If you will look at the paper, it will look like this. You will be writing like this as your answer. Now let's proceed to the next question, the orbital box notation. But we will do first the number of valence electrons and Lewis dot structure class because it's pretty easy. They are pretty easy compared to the one, two. So we have here the longhand form. In order for you to know the number of valence electrons, the technique that you need to remember is that go back to your longhand SPDF notation and find the highest energy level. So the highest energy level here is the 5, the fifth one, the fifth level. So this fifth level, you need to look at how many sublevels it uses. So it has S, okay? So it has S having an electron of 1. So it means for the fifth sublevel, the number of outermost electrons, or known as valence electrons, is 1. The answer is 1. Because for 5, there's only 5s1. However, if there's no 5, example only, it's until only 4. So you will count how many electrons for 4. So we have 4s2 and 4p6. So the answer is 2 plus 6 equals to 8. If until 4 only for this given example. But we have 5, so it is only 1. So the answer is 1. Now, let's proceed to the Lewis dot structure. In making the Lewis dot structure, you need to write the symbol. And the element that we had a while ago, it's rubidium. It is a symbol of Rb. So you will put a dot wherever you want, here, 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 or here. And this dot should represent the number of electrons that an element has. So this one. Since rubidium has only one valence electron, you will put only one dot. So as what I've said, if you don't want to put here, you can put here 1. If you don't want to put here or here, you can put here 1. If you don't want to put here or here, you can put here 1. So this is the answer. You will be looking at here, we have now the answer for the number of valence electrons and the Lewis structure. We are still trying to find what's the answer for the orbital box notation and Bohr model structure. So let's do it. Let's have first the orbital box notation in relation to the condensed form of its SPDF notation. So we know for a fact that we use the noble gas krypton as the isoelectronic of rubidium. Okay, so if we will be making the orbital box notation, as what I've said, if you will be making an orbital box notation for krypton, it will be too long. That's why you can write krypton only. Then the remaining ones, they are the ones that you will be having the boxes. It depends on the number of next levels here. Okay, so for this one, we have Kr krypton 5s1 only. So this one represents to the number of the electron under the S sublevel for the fifth energy level. So we have 5s1, so one arrow going up. So if example 5s2, you will have one going up and one going down. Remember, for S sublevel, there is one orbital only, and this orbital can hold a maximum of 2 electrons. So the answer for this part will be like this, that's what you can see. Now, the last one that you need to do, which is the one that will consume a lot of time because you need to draw and you need to create the structure, is the Bohr model. So we will write again here the longhand form SPDF notation of this element, and I decided to put a distinct color for each level so that you will not be confused, because some of the students, when I roam around during the time, you were confused class. I taught you like 8, 18, 32. For 2, 8, 18, 32 class, it refers to the number of electrons an energy level can hold, but it depends on a certain element. Okay, not all elements that for the third energy level they will be holding 18. Not all elements that for the fourth energy level they will be holding 32 because they don't reach the maximum number. So you need to follow the guide. So this is the guide, the longhand form. Here, the first thing that you will be doing is to make or to write the number of number of protons and neutrons, and we know that these two subatomic particles, they are the ones creating the nucleus. Next is you'll be drawing the, or you'll be making the number of energy levels that you will be having. So by looking at the longhand formutation of rubidium, the highest energy level here is 5. So it means you will be having 5 circles. Okay, 1, 2, 3, 4, 5. Okay, next we will fill in each energy level with the number of electrons it has for each energy level. So for the first energy level, it has S here, the sublevel, and this S has two electrons. So 1, 2. Now for the second energy level, it has two sub-levels here. We have the S and the P. The S has 2 and the P has 6, so a total of 8 for the second energy level. So you will be putting 8. 1, 2, 3, 4, 5, 6, 7, 8. Now, for the third energy level, we have this one, 3s2, 3p6, and 3d10. We can, in order for you not to be confused, but it depends on the student and how you will do it. You can do this one first, like 2 plus 6, it's 8, so you will put in 8 for you to be guided. So we have 8 here, 2, 4, 6, and 8. We're done with this two sub-levels for the third energy level. Now let's proceed to the fourth energy level. For the fourth energy level, we have two sub-levels here, the S2 and the P6. But the first one here is the 4s2. So we can put 2 first, 1, 2. Now let's go back to the third energy level because it says here after 4s2 we will have 3d10. So we need to put 10 electrons in the third energy level. Go back here. Okay? So if we will be counting the number of valence, I mean the number of electrons, now let's go back to the fourth energy level because it has P6. Okay, the sub level P having 6 electrons. We will be putting 6 again. 1, 2, 3, 4, 5, 6. And now for the fifth energy level, it is only 1, so we will put 1. 1 dot. Okay, 1 electron represents 1 dot. Now, if we look like this, if we will be answering in the sheet that I gave you. That's all. Thank you.